Our first topic is inheritance. So what is inheritance? It is the process in which the properties of base class is inherited by derived class. There are many types of inheritance: single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. We will discuss each of these inheritance one by one. One of the most important concepts in object-oriented programming is that of inheritance. Inheritance allows us to define a class in terms of another class, which makes it easier to create and maintain an application. This also provides an opportunity to reuse the code functionality and fast implementation time. What is base class and derived class? A class can be derived from more than one classes, which means that it can inherit data and functions from multiple base classes. To define a derived class, we use the class derivation list to specify the base class. Base class is also called as parent class. Derived class are the classes which are derived from the base class. This process is called as inheritance. So the first type of inheritance we will discuss is single inheritance. So what is single inheritance? When only one subclass is derived from the superclass is called as single inheritance. Single inheritance enables a derived class to inherit properties and behavior from a single parent class. It allows a derived class to inherit the properties and behavior of a base class, thus enabling code reusability as well as adding new features to the existing code. Multiple inheritance. This is the second type of inheritance. When a superclass is derived from more than one superclass, then the inheritance is called as multiple inheritance, as you can see in the diagram. Multiple inheritance is a feature of C++ where a class can inherit from more than one classes. The constructors of inherited classes are called in the same order in which they are inherited. The third type of inheritance is multi-level inheritance. It means the subclass is derived from already derived class, then such inheritance is called as multi-level inheritance. The level of inheritance can be extended to any number of levels depending upon the relation. Multi-level inheritance is similar to relation between grandfather, father and child. As in the other inheritance, based on the visibility mode used or access specifier used while deriving the properties of the base class as derived. Access specifier can be private, protected or public. Hierarchical inheritance. The process in which more than one subclass is derived from only a single superclass is called as hierarchical inheritance. This means that we can derive as many as we want the subclass from the superclass. Thus, when more than one classes are derived from a single base class, such inheritance is known as hierarchical inheritance, where features that are common in lower level are included in parent class. The fifth type of inheritance we will discuss is hybrid inheritance. Actually, it is the mixture of all the inheritance that we see one one. Hybrid inheritance in C++ inheritance is the process by which objects of one class acquire the properties of another class. By this, we can add additional features to an existing class without modifying it. Hybrid inheritance is used in a situation where we need to apply more than one inheritance in the program. It is widely used inheritance as in other inheritance based on the visibility mode used or access specifier used while deriving. The properties of base class are derived. Access specifier can be private, protected or public. Now we will discuss about function overloading. C++ allows you to specify more than one definition for a function name or an operator in the same scope, which is called function overloading and operator overloading respectively. When you call an overloaded function or operator, the compiler determines the most appropriate definitions to use by comparing the argument types you have used to call the function or operator with the parameter type specified in the definition. The process of selecting the most appropriate overloaded function or operator is called overload resolution. This is what is function overriding. If derived class defines same function as defined in its base class, it is known as function overriding in C++. It is used to achieve runtime polymorphism. It enables you to provide specific implementation of the function which is already provided by its base class. Suppose both base class and derived class have member function with same name and arguments. If you create an object of the derived class and call the member function which exists in both classes, the member function of the derived class is invoked and the function of the base class is ignored. This feature is in C++ is known as function overriding. Polymorphism. This is another important concept of C++. The word polymorphism means having many forms. Typically, polymorphism occurs when there is a hierarchy of classes and they are related by inheritance. C++ polymorphism means that a call to member function which cause a different function to be executed depending on the type of object that invokes the function. Now we will discuss about the virtual function. A virtual function is a function in the base class that is declared using the keyword virtual. Defining in a base class a virtual function with another version in derived class signals to the compiler that we don't want static linkage for this function. What we do want is the selection of the function to be called at any given point in the program to be based on the kind of object for which it is called. This sorting operation is referred to as dynamic linkage or late binding. Okay, we have studied now virtual function, but why do we need virtual function? Virtual functions are used to support runtime polymorphism. When the virtual function is called by using a base class pointer, the compiler decides at runtime which version of the function, that is base class version or the overridden derived class version, is to be called.